Greetings, I'm Minhajul Abidin Tajik. Welcome to our presentation for our very first project on remote sensing with Landsat data. So my teammates are Rituparna Talukdar and Arif Noor. So for our project, the area of interest was Chambers, Texas County. There, it has an area of 871 square miles, and is located in the Gulf Coast region of Texas, approximately about 35 miles from the Houston. And our timeline was from 1984 to 2024, basically 4 decades. So we collected our we collected our Landsat data from Earth Explorer. We selected the Landsat C2 analysis ready data for our later analysis, and we also got the Texas boundary from TexDot. So for the data, when we were filtering it, we considered cloud cover of 0 to 5%, and after that, after downloading the data, we had to do some pre-processing to make the data for our later to prepare the data for our later analysis. So the pre-processing includes mosaicing, masking, cropping, combining, resampling, and we tried to make use of R throughout our project so that it would make our analysis more easier later on. So you can see there's a snapshot of a code that loops through the TIFF files, and so mosaic seeds and make a composite out of it. So after that, we did some exploratory data analysis that include histogram equalization, which also is known as increasing the contrast. So basically, we can see here there is two histogram, one that has like long spread, and another one which is compressed. So what we did, we tried to get rid of the outlier values and set the quartiles, the first quartiles and the third quartiles as 5% and 95%, and we use the function clamp to clamp it all together, clamp the data all together and make another composite for our later uses. We can also see how the contrast of the image increased by doing that. So the later on, we also did perform the principal component analysis or PCA on our dataset, because there are a huge correlation between the data. So we had to make sure our classification is not biased, and we also wanted to reduce the dimensionality of the data. So we performed the PCA and took the scores out of that, and from our analysis we saw about 98% of the data of the variance is covered by PC1, PC2 and PC3. So we took those data for our later classification. So we try to plot the PCA loadings and to show how it changes over time. So here I have PC1 loadings from 1984 to 2024. It is as per the band types. Like we can see 6 bands over here, how the PC1 loading is changing over time. So there can be several reasons behind this change. It can be like seasonality. Another thing can be land use change. Another one can be agricultural behavior change. people can switch to crops that doesn't have much more chlorophyll than before. So there are lots of things. So the one to be interested is band 4. It describes the health of a plant. Like it is mostly it focuses on the chlorophyll content of the vegetation. So we can see how the graph is fluctuating, but it's really difficult to describe the land cover or land change based on only PC1 because it only covers the variation of data of 68%. So there are other dimensionality based on PC2 and PC3.
Hello, I'm Rituparna. Now I will talk about unsupervised classification. Before going into that, we perform node optimization using Kmeans to find the optimum class number for our analysis. Here we used elbow method to perform the optimization and used 1 to 10 nodes and got this plot. From this plot we can see at the node number 4 the curve starts to flattening. So based on this elbow method 4 is the optimum node. Our first classification method is K-means. It uses distance from node to find the classification result. We use the optimized node from the previous elbow method result and used it on PCA scores. From PC1 to PCA3, and the raster resolution used for this data was 30 by 30. Here we have provided the code we use to clustering our data, and this plot classifies our data into 4 categories. 4 colors are defining 4 types of clustering. The next classification method is HCA. We use the optimized same node from the K-means method, trying to make the analysis consistent. HCA is a really computational resource exhausting method. So especially for a large data set, we have taken 200 by 200 meter resolution to reduce the data size and performed separate PCA on it, which we used in this classification. Here we have provided the code we use to perform our clustering, and from this plot we can say that from the previous plot it has less data and the data are more clustered or more specified with its classification.
After we get the results from the K-means clustering and HCS clustering, we need to define or assign the cluster number, the result, to, as different classes. So since we have 4 classes, we need to find 4 majority classes in our study area. For Chambers County, we can see that it's dominantly have agriculture area, vegetation, wetlands, and developed area. So we need to generate that, and we were using the Google Earth Pro because the Google Earth Pro has the ability to change the timeline of the figure, so we can see the, let's say we see the developed point, let's say a museum or courthouse. So we check if the courthouse already exists from 1984 until 2024. So it will consistently give us the information of develop. Also, we do that for another classes. Another option to generate a ground counterpoint is using the NLCD or National Land Cover Dataset from MRLC website. This is a dataset generated from the USGS and already assigned with different classes. So let's say we randomly generate 500 points distributed randomly, and we can pick or extract the information of the location of the points to compare with the classification results. So that's another option to how we can assign the cluster results from the clustering. However, the NLCD data are limited. The USGS provided the NLC data from 2001 until 2021. So we need the information from previous 2001 and after the 2021. So we consider to use the GCP point from Google Earth Pro. The assumption we made to do our Landsat clustering. First, the cloud cover and pre-processing. So we exclude the scenes or images with high cloud cover from the before the analysis, because we need the information of surface reflectance. Therefore, we need the minimum amount or zero cloud cover. For spatial resolution, the Landsat data typically has 30-meter resolution, and it's enough to capture land cover features. But we need to resample the Landsat data to 200 by 200 meter to do the HCA clustering because of the computational resources. And for ground control points, we accurately represent the land cover classes from the Google Earth engine, Google Earth Pro. As for land cover classification algorithm, the GCP accurately represent the land cover classes, and we assume that the GCP has have same cluster number throughout the analysis. So let's say we have four cluster 1, 2, 3, and 4, and we assume that throughout the time from 1984 to 2024, the cluster 1 is consistently, let's say, assigned as open water. However, after we got all the result, the cluster is not consistent, are not consistent. Therefore, in the we will say something for the future analysis. And for the land class, we assume to take 4 cluster to represent the 4 land classes based on the elbow method. So overall, a core observation has been done on the dataset. And for data quality and consistency, the Landsat data acquired across different decades from 1984 to 2023, and consistent in terms of sensor radiometric classification, atmospheric classification, or geometric accuracy, because we are using the Landsat data, the analysis ready data type. So we assume that we just can use the Landsat ARD to do the analysis. So this is the result of our Kmeans clustering. The left side is 1984 and the right side is 1993. It's like one decade of image. We can see that the blue one is open water, the green one is the vegetation, the light blue are wetlands, and the yellow one are agriculture area. So that's how we define our clustering result. And compare from 1984 to 93, we can see the change. We can see it's so different from the 84 and 93. And later on, we will show you the number of the percentage of each classes. So based on our assumption, so the cluster one is consistent. So we generate the time series of the loading of cluster number one from PCA1. As you can see, it's fluctuative over the year from 1984 to 2024, and the lowest one we can see at the 1984. And generally the percentage is more than 40%. For cluster number two, also distributed randomly, we from 84 to 24. The lowest one happened on 2004 at 3.49%, and the highest value is 52.7% on 1998. So this is the result of cluster number T. Basically, not consistent. And this is the cluster number 4, and the highest one is 43% during the 2004. So this is the result of the HCA classification from 84 to 2024. Later on, we will assign the class, the color, the result with a better presentation with legend, and also a better presentation. And better show the numbers so it can be easily understand how the land cover change over the time. So some of the data are some of the image has no data due to the error of the sensor for Landsat 7. And then this is the result of Kmeans clustering. It's more detailed. The results are more detailed, and we can see the change of clustering result or land use land cover change over time. Oh, I'm sorry. This one is the Kmean result from 1984 to 2024. We can see the result is more detailed because we used resolution of 30 meter by 30 meter. And later on we will assign the color and the legends to show you about the land cover change over the time. And for future implication, we will reclassify the raster based on the GCP points to make a consistent land use land cover spatial distribution. Also, the ACR result can be improved and give more finer classification with finer resolution and more capable and do with a better capability of computational results. A transformation matrix could be generated to give a wholesome picture of land use land cover change over the decade. So that will be our presentation for the assignment. Thank you for watching. Goodbye.